In pressure pipe welding, an electric arc reaches temperatures exceeding 6,000 degrees to fuse steel. Maintaining a sound molten puddle against the pull of gravity is the primary test of a welder's skill. To prove this proficiency, welders aim for a specific industry benchmark, passing the 6G qualification test. Consider a common case study. A welder passes a performance test using the shielded metal arc welding process on a 2-inch Schedule 80 pipe made of ASTM A53 carbon steel, fixed at a 45-degree angle. Once the test is complete, we have to determine exactly what this individual is legally permitted to weld on the production floor under ASME Section 9. This requires a distinction between testing a procedure and testing a person. A welding procedure specification, or WPS, qualifies the chemistry, heat input, and metallurgical viability of the joint. A welder performance qualification, or WPQ, is different. It strictly evaluates the human's physical ability to deposit sound metal within defined geometric constraints. Section 9 uses the physical parameters of that single test coupon to calculate a definitive boundary for the welder's production limits. The first parameter to evaluate is the 6G position. This orientation is physically demanding because it requires the welder to transition through flat, vertical, and overhead techniques in a single continuous pass. Paragraph D of the code defines the 6G position as a pipe fixed with its axis inclined at 45 degrees, where the weld is deposited as the welder moves around the circumference. Because this is the most difficult orientation to master, the code grants the welder the broadest positional qualification range for passing it. We can find these specific limits in the welder performance qualification table. We'll look at the fourth row labeled Pipe 6G. Note the designations in the subsequent columns. Successful completion of this test qualifies the welder for all positions on plate and on pipe with an outer diameter exceeding 24 inches. It also covers all positions for pipe diameters ranging from 2 7/8 inches up to 24 inches. Finally, the qualification extends to all fillet weld positions. Essentially, the 6G test removes positional restrictions for this welder on the production floor. Next, we analyze the base metal chemistry of the test coupon. Our example coupon uses ASTM A53, a standard carbon steel. If welders were required to retest for every proprietary alloy on the market, the industry could not function efficiently. To solve this, ASME uses the P-number system, which groups materials with similar weldability and mechanical properties into shared categories. In this list of base metal P-numbers, we can identify where carbon steels like A53 fall. Carbon steels are classified as P1 materials. Under performance testing rules, qualifying on one P1 metal allows the welder to work on any production material within the P1 group. This grouping ensures the welder's metallurgical range is fixed to carbon steels without requiring a new test for minor alloy variations. The final two variables are outer diameter and wall thickness. These create the most significant restrictions on the welder's scope of work. The starting diameter for our coupon is 2-inch nominal pipe size. It is important to note that NPS is a naming convention. A 2-inch NPS pipe has an actual outer diameter of 2.375 inches. We must check the code to see what a 2.375-inch test qualifies for. In the lower section of this qualification table, we find the row for test coupons between 1 inch and 2 7/8 inches. Our pipe fits this tier, qualifying the welder for any production pipe with a minimum diameter of 1 inch up to an unlimited maximum. Finally, we must calculate the limit for the thickness of the deposited weld metal. A 2-inch Schedule 80 pipe has a wall thickness of 0.343 inches. This measurement determines the welder's thickness bracket. In the top table, the first row applies to coupons under 3/8 of an inch. Here, the code applies a 2T limit. This rule states that the maximum thickness the welder can deposit in production is limited to twice the thickness of the metal deposited during the test. For a full penetration weld on our 0.343-inch coupon, we multiply the thickness by 2. This results in a hard production limit of 0.686 inches. While the diameter range is broad, the thin wall of the test coupon creates a mathematical ceiling on the thickness of the joints this welder can legally weld. By combining these data points, we establish the final operational envelope for this welder. They are qualified for all welding positions on P1 carbon steels. They can weld pipe diameters from 1 inch to unlimited, but are strictly limited to a weld thickness of 0.686 inches. To qualify for unlimited thickness, the test requirements must change. Section 9 requires the test coupon to be at least a ½ inch thick, using a minimum of 3 weld layers to qualify the welder for unlimited thickness on the production floor. The practical implications are significant. If this welder is assigned to a 1-inch thick joint, the work would be AV compliance, even if they hold a 6G certificate. Using a welder outside their qualified range results in mandatory cutouts and significant safety liabilities. The 6G test covers all welding positions, but the actual scope of work is still bound by the physical dimensions of the test coupon. Mastery of the code requires verifying these specific limits before the arc is struck.